Tony, what are you taking a picture of? Why? Why?
Alright, you guys can title this when we are looking at robot situations, we don't call it slope, we call it rate of change. But you can do slope of a line or rate of change of a table, word problem, it's all the same thing. How much one quantity is changing in relation to another. And this is called rate of change formula or slope formula. And this is exactly what you guys were all doing with the table. You subtract the y values and you divide that by the difference in x values. So you guys were all just kind of naturally doing that. Rate of change or slope formula. You can call it either one. That's synonyms. Rate of change and slope. And the rate of change we call m. M for movement, M for most movement. And it's going to be, you're going to subtract your y's on top, and then you divide that by the difference in x's.
Wait, can you go back, please?
What do you don't need to write all this.
We don't?
No.
What do we need to write?
This.
I already wrote all of it. I already wrote every single one. Like a playboard.
Is everybody good?
Yeah. Wait, I need it. Oh yeah, you can.
I'm gonna go since I wrote it on the board. I'm
What
gonna
up?
go.
Any of these down?
All right. So look at this table. It's about entertainment. Use the table to find the rate of change, then explain its meaning. So you guys just look at the table like you just did. You need me to zoom in on it? I can't. So how much changes between 78 and 156? Use your calculator. 156 minus 78. 78. And then how much are the x's going up by? 2. So we'll do 4 minus 2. We get 78 divided by 2 or 39. So this means that each computer game costs $39. No. Let's write the next one. You do not have to write all that.
Wait, 78 plus 78 is. Yeah. It's 156.
Yeah. Plus 140 and 16.
And then 7 times 8 is 56. That's kind of cool. Yeah.
I think that's a coincidence, but let me know if you find a correlation. Alright, you're up. You're up. You have to do this one on your own. This is the one that you have to write. Remodeling. The table shows how the tiled surface area changes with the number of floor tiles. Find the rate of change and explain the meaning. I want you to use the formula. Subtract the y's, write it over a fraction bar, subtract the x's, and divide.
So we can just pick two random things? Okay.
So for our remodeling rate of change, I'm going to do 96 minus 48 over 6 minus 3.
I'm doing that.
Oh, no. Yeah, question it. Question it. You never know. Definitely question it. You should not just be sitting there with your brain turned off writing things down. You should be questioning it. What is it? Can you tell me what you got right before 16?
Oh, I subtracted the
So it must be 48 over 3, which is 16. No. Wait. Logan. What does it mean? No, more than that. Let's use the words. No, you gave your number. I'm looking for somebody else. I haven't heard from Logan today. Haven't heard from Benjamin and Thomas today. One of you three. Let's hear it. What does it mean? What do the Y's represent?
area of tiled surface.
Okay, so this is area of surface. Guess I can get rid of that with my hand, which is always uncomfortable. Area of surface all over 1. What do the X's represent?
Number of floor tiles.
Number of tiles. No, yeah, write that. And still we're looking for a sentence.
I got it.
Patrick.
Per floor tile, it covers 16 square.
Per floor tile, it covers 16 square inches. I'm going to go with the word each. Each floor tile covers an area of 16. Or you could say, if 16 square inches are covered, if the area is 16, then 1 floor tile was used. Say it like that. Let's try another one.
Um, 38. Yeah, it's 38.
Just go with the rest. Listen, I hear everyone calling out 38, but I'm less interested in 38, and I'm going to challenge you. Write a sentence explaining what 38 is. Just wait. Give everyone a chance.
Time drive. We're traveling 38 miles per hour.
38. And the y values is distance. The x values is time. Okay, Kaden. In 1 hour, they drove 38 miles.
Your way to say that. Yes. They drive 38 miles per hour.
You could say they drove 38 miles per hour.
Yeah.
Both are equally good. Let's see what's next. Oh, that's it. Great news. We can now start your assignment. Oh! Oh, wait.
Whoa!
Fail after fail after fail. Alright, let's try one more. Sorry. It's gonna be okay, guys. The graph shows, Benjamin, what's this graph all about? Let's go further back. Can you read it, Kalia? What's this graph about? Passwords. The graph shows the number of passwords issued between 2012, 2014, and 2016 Find the rate of change between 2012 and 2014. Pay attention to the scale of the y-axis. This must be a challenge question. Hey, I'll help you guys out. It's kind of hard to see the ordered pairs. So for 2012, the ordered pair, I'm going to call 12, 13.1, and we're going to call that X1, Y1. For 2014, the ordered pair we're going to use is 14. 2 years have gone by, and there was 14.1 million passports. We're going to call that X2, Y2. So for the formula, Y over X. Changing Y over changing X. We're going to go, we call it M. 14.1 minus 13.1 over 14 minus 12. What does it mean? Tyler. Look at Tyler pulling out 500,000. There are 500,000 or 500,000 passports. What do you do? Do you give a passport? Do you award it? You issue them. Issued each year between 2012 and 2014. Everybody on board with that? It was 0.5. And the reason it says pay attention to the scale of the y-axis because it says in millions, so that's 0.5 million each year. So Tyler said, well, 0.5 million is 500,000. That was a good interpretation. You guys, what happened from 2014 to 2016? How would you describe that situation? It rose a lot. Some kind of maybe a global crisis. Maybe they just relaxed on the passport laws. Something different changed. Was there maybe a presidential change, an administration change, some kind of law change there? It was something political happened. Maybe someone was trying to get more votes. That's what the media would say. But could it be something more meaningful than that? It could. Well, would it work now, you little geniuses? I got it right this time.
Good job, Miss.
Alright, you guys.
That's the same question.
Find the rate between 2014 and 2016. Let's actually figure out how much it went by. How do you have this answer already? How do you know it already? Oh, you already did it? Well, let me show the math. Joseph, can you see the graph? So my first ordered pair is going to be 14 comma what? 14.1. My second ordered pair will be 16, 18.7. Can you please set up the formula for me? We're actually going to do the second one minus the first one. Okay? Alright. What's that math? 4.6 or something? Okay, 2.3 over 1. Joseph, what does it mean?
Yeah. 2,300,000 passports issued this airport.
2.3 million passports each year. It went from 500,000 to 2.3 million.
Whoa. Oh my god.
Somebody needs to know this. You guys tell your history teachers.
This can't be true.
Maybe.
We got it wrong.
You guys, please talk to your history teachers. What happened?
It was about
No, I think this data is real, but it could be completely related to. No, it's definitely political. I was gonna say September 11th, but
Let me soft stretches.
all done. You guys did great on that. Now open your workbook. Because I found that one question. Oh, it's so sad when you get one question wrong and it's a 66. You guys open your workbooks because I have to show you how different your homework is than what I covered in class, which is a student's favorite thing. Do you guys like it when your teacher assigns homework that doesn't look like your classwork? Right, so starting with 1 through 3, they're just offering a picture of the graph, not a table. And actually, there's no tables on this whole thing, but the slides I went through were just some tables. So all I want you to know for this whole, like I gave you a lot of practice, is you're doing y2 minus y1 over x2 minus x1. And you're finding rate of change with these lame old numbers. For class, I could have just done this with you, subtracted numbers. I find that really boring. I didn't want to do it today, so that's why I brought in the tables. But here, you can just find the numbers for my first ordered pair. 0, 1, I call that x1, y1. And for 2, 5, I call that x2, y2. So I'm going to do 5 minus 1, 2 minus 0, and I get 2. And you don't even have to explain what it means. You're just getting a number out. So this is literally just repetitions for repetition purposes. I want you to memorize this formula until you're done school. So you're done schooling, you'll use this formula every year in math class. There isn't a single further math curriculum that does not use this formula. Algebra 2, geometry, calculus, they all use it. It's what? Yeah. So maybe I'll jump to number 5 and do that one with you really quick. Which other one has zeros, Kato? You guys, let's talk about the difference between 5 and 6. Undefined. So 5 is undefined, 5 is 0, while 6 is called undefined. You see that, Libby? This one's 0 with the 0 on top. When the 0's on bottom, we call that one undefined. I didn't tell you this. This vocab.
Whenever a 0 is in any equation, does that make it like not?
This one's good. This is a real 0. Zeros happen.
Okay, so if a 0
This
on top,
one's
it's
bad.
0.
Yeah.
Okay.
This one's bad. 2 doesn't divide by 0. This is considered non-functioning. Just 0 slow. And the other one's undefined. It's -3.